Okay, good afternoon. My name is Morana. I'm a senior consultant within Financial Professional Services, Division McAfee. The scope of my talk is to introduce a business case for building security in the software lifecycle. And this business case is based upon common knowledge of security development lifecycle and our experience with clients and some data from public data available from case studies. So the outline of presentation I will talk about in the glossary. I will just cover some common terminology that I'm going to talk during the presentation. I will put some emphasis between application security and software security with a different perspective. I will mention some data you can use for making your business case based upon the cost of application security versus software security, and the metrics you can use to talk to the executives, which is the return of security investment, for which you can make the business case and the cost-benefit analysis. I will introduce to you different ways to implement the software development lifecycle, so based upon process models quite available right now, or how to build your own framework based upon our consulting experience with clients. We'll put some emphasis on integrating a business impact and technical impact in order to lay down the risk remediation strategy. And then in the summary, I will give you some lessons for you to take away. Information security risk from the perspective of information risk management is the probability that a particular threat source will exercise a vulnerability, resulting in an impact, and impact can be both business and technical impact. This is based upon a NIST publication on the information risk guideline that you can actually look yourself on the NIST website. A very good definition of most of us in the industry know the difference between software security and application security, but somehow it's misused, especially in some commercial applications. The best definition I find out is from Exploiting Software, a book from Gary McGraw, which is an academic leader in the field. And so software security is a way to defend against software exploits by building secure software, whereas application security, you kind of like tackle the risk when the software and application is already deployed. A return on security investment is the definition we take here is from Microsoft Security Risk Management Guide, which is the total amount of money the organization is expected to save in 1 year by implementing security control. And this metric is used to decide the cost benefit of implementing security control during the risk management. So let's talk about risk, where they are, and if you look at the evidence, if you like evidence, I was actually watching on TV a CSI investigator. The CSI investigator say, oh, I don't believe what you're trying to tell me, I just believe the evidence. So the evidence is that 92% of vulnerability right now reported are in applications, not on networks. So if your client is very network-centric, using the network-centric approach, is primarily concerned about deploying firewalls, deploying IDSs, and spyware, this is a good case you can make. And this 92% includes server and non-server application and operating systems vulnerabilities. How we approach risk from the standpoint of application security versus software security. When in software security, we approach risk from managing risk throughout the software development lifecycle. So we look at the problem from the perspective of the root causes of the problem. In application security, we look from the tactical point of view. We just look for a fixed-up solution. We look at the issue. Very typical example, buffer overflow. I can tackle buffer overflow from the standpoint of software security and look at the input validation issues. Or I can just apply the patch. This is the application risk, the application security approach. So think about it, because whatever you're talking about application security, you're kind of like limiting your scope. And this is shown in this diagram here. Really, software security is thinking about all the big components. They are part of the process, technology and people. So which are the costs? These are public data you can take are quite available. You can make the case from the standpoint of application security is very expensive. Think about, on the average, you will get between 5 and 15 defects for 1,000 line of code. You can factor how many hours, many hours it will take to research the problem, to find the solution, and develop the solution. And so, and you extrapolate for 150 hours per defect, and you come out with these numbers. Patch management, these are the costs that impact the total cost of ownership. These are the costs that impact the vendor, not the vendor, but your client actually using your software. So 1,000 server, deploy the patches for 1,000 servers, test the patches before being deployed. These are the costs, and these are data from Gartner, quite reliable indeed. Or you can think about the impact of losing productivity because of a degradation of a service, of a completely loss of a service. And so this is the data based upon the black year 2001, when for a few days the Microsoft servers were attacked by named and code red. So from the perspective, so you can make a strong case based upon these data. From a perspective of software security, when you're not tackling the risks from the beginning, you end up finding defects at the end when it's too late. And so what happens, you're going to allocate man hours from other projects just to try to get the project released. Again, data from Microsoft, how much the IT department was tracking down resources to be allocated in different departments in order to fix the security problems. And 1,000 man hours being allocated just to get the releases done. If you have your data already, if you're already tracking, you have a metric and measurements within your organization, of course, you can use those data, but this is just to make you, to point out which data are important to look for. Of course, there is no such a thing like free lunch, so if you're going to implement security in your software lifecycle, you're going to spend money on training. So $100 million were spent on 2001 by Microsoft for implementing the Trustworthy Security Lifecycle Initiative. And of course, you can have big numbers you can apply to, like the cost of inadequate software testing costs. That counts in the billions. When do we address the problem from the software security perspective? This is an old study made by Capers-Jones in '96, but it's still valid today. If you look at the percentage of bugs that have been introduced during the software life cycle, which is the light blue line, 85% of the defects are normally introduced during coding. But when we do something about it, when we actually found the defects, it's just late in the software life cycle. If you look at the yellow line, it will tell you clearly that we found most of the defects during the testing phase. How this is impacting the cost? This is impacting the cost from coding to unit tests to function tests exponentially. So what that means is that when we spend only $25 to address the problem when it happened, to fix the security defect during coding will cost me 4 times during unit tests, 10 times or 400 or 640 times during the operation. So with this diagram, you want to say, I want to stay on the left of the ground. I want to tackle my security defects as early as possible in the software life cycle. And this method is okay when you're talking to project managers that they need to allocate resources. But when you need to have customer buy-in, or your executive buy-in, from the standpoint of implementing security, what you are going to talk about? The question you will be asked is, when is more effective? I have different options. Which one is the more cost-effective to implement to? You cannot go to an executive and say, oh, we need to invest $100,000 in security, otherwise we'll be hacked. An executive will ask you, I want options. I want a cost-benefit analysis. So you can use the data. This is a major study being provided actually by Kevin Su, a stake using data from IBM and other vendors. In this data, the return of security investment is shown that the return of security investment in terms of dollar saving is much higher when the defects are fixed and identified during design. So what that means is, if I engage in security engineering activities during design, like architectural risk analysis or threat modeling, I have much more benefit than to wait later during the testing. Software development life cycle is really managing software risk throughout the life cycle of the development of the software. And this is really the nice picture that we would like to achieve. Out of many security activities, we have one secure process. And you build this based upon foundation. It's not just the process itself, it's also people and tools. You have a matrix that is already implemented, fine. Leverage that matrix for example, software quality assurance. Integrate this with a security metrics as well. How do we get there from the perspective of our customer experience is by adopting an activity-driven approach. And this activity-driven approach, the activity are derived by best practices. Best practices are security requirement engineering, are secure coding reviews during the coding, are secure testing. So based upon a customer experience, define clearly in your guideline what these activities are. Also define for each activity dependencies and prerequisites. For example, if I need to do threat modeling, I may need to do before use and misuse cases, or which artifacts are needed for each activity. For example, for threat modeling, I may need architectural design diagrams to do my analysis. Define entry scenarios for each activity means like event triggers. You can use action diagrams to do that, to define what I have to do if I am engaged in the software development of, for example, defining the requirements. I can trigger an activity of evaluating secure requirements. Very importantly, this point 5 is the one most important, I think. Define both a strategic and a tactical plan for those activities. A tactical plan is the plan that you can implement in a short time, like in 1 week, for example. You can do like a whiteboard exercise and understand the application, and then issue some remediation strategy based upon initial assessments, like, for example, penetration testing or a code review or a threat modeling. You can get the benefit in a short time. These are, from our client perspective, these are band-aid activities. But also think what you can do strategically as a next step. Define roadmaps for the activity. Like you may have a software is already developed as your legacy software, and the application is already in production, or the application has to be in production. So define roadmaps for the two alternatives. Position the activity. If your company is adopting different methodologies for software development, position these activities for those methodologies. So if you develop software with Agile or XP or Waterfall or RUT, identify how you can build in software and these methodologies as well. The important thing is that your methodology has to be agnostic, is independent from which kind of software development methodologies you are implementing. What it provides you from the standpoint of common knowledge, what common knowledge provides you are security enhancing life cycle process models. They are basically based upon assessment, verification, and measurement. So they enhance security through repeatable and measurable processes. They provide guidance. So they provide basically for each activity what the activity is, what it needs to be done. They provide software security development reviews, like, for example, code reviews or reviews before deploying the software. They are all articulated what you have to do as far as the activity, which kind of tactical resources you can use, for example, checklists, common vulnerability lists. They provision the use of automation tools. For example, in the case of CLASP, the categorization of vulnerability maps to the use of source code parsers that have been used by the methodology. Some activities suggest some roles and responsibilities, and also integrate with foundational development activities such as patch management, change management, other activities the company is using for developing software. From the perspective of security enhancing process model, there are several out there. The company that certainly has more experience in the field is Microsoft. You find a lot of resources out there about the trustworthy computer security development lifecycle. There's been actually a book recently published by Stephen Lipner and Michael Over about the DSDLC that I strongly recommend to read. CLASP stands for Comprehensive Lightweight Application Security Process. It's lightweight because it can be applied to any software development methodology. It's based upon best practices that apply to the CLASP lifecycle. The CLASP lifecycle is very comprehensive because it deals with software that from inception to operation. Very importantly, CLASP can also be iterated to wrap any methodology, evolutive software development methodology you may have. Important is also an open source project now because it's been given to Hovis, so you can get all the resources. Another academic leader in the field is certainly Gary McGraw. He rationalized his input about the security from the standpoint of touch points. And touch points are really activities that can be built according to best practices in any software development lifecycle. A book also has been published this year, Secure Software, that was also here down the hallway, so for purchase. The Software Engineering Institute also been expanding the team software process to include secure software development. So there's a lot of emphasis in this methodology about a team review, a principal review, and metrics and measurements. So you can get a lot of resources out there and it's free. So how we can put all things together from the perspective of context. And this is a diagram based upon a similar diagram that we developed for one of our client engagements. And what it gives you all the context of the activities, the best practices. And on the top layer, you have the SDLC phases. They map to software security best practices. Software security best practices map to ongoing activities that can be performed throughout the life cycle, like metric and measurements, training awareness, for example. You can group software security activities from a standpoint of common objectives. And also, if you can identify with a crossbar the interface with other security practices that are being adopted by the organization. For example, if the organization has already a technical risk assessment, this one is going to interface with your threat model. So you provide the input of your threat profile in order to assess technical risks. And then once you identify this technical risk with the business input, business impact, you can also feed the information risk management, which are basically all the practices that are here on the bottom. The defect management, change management, they are not really practices of the SDLC, but somehow overlap with the SDLC practices. So with this, you can define the context from the perspective. I have already information risk management guideline that covers some aspects from the organization, the way we manage security in the organization. How I define the context between security risk management and information risk management. With this diagram, you can actually define the overlap of the competences. Very critical is integrating business risk and technical risk in order to define a strategy. This is a very loosely concept because when we do threat modeling, what we tackle are technical risks. It's a risk basically to have software failure. We don't evaluate the value of the asset. We just evaluate the data. So, so if you have a very clearly defined information risk management, take into account the business impact from a standpoint of evaluating the assets, and also takes in consideration these technical risk factors from a standpoint of evaluating the data and finding the technical impacts. When you put all this business impact and technical impact together, you can lay it out a risk remediation strategy. Finally, you can make the case for how much does it cost to fix my vulnerability versus how much is the cost of exploitation of the vulnerability. And this comes by translating technical risk to business risk, and then also comes from prioritizing according to the business impact your countermeasures. So in summary, make the business case not based on FUD, fear, uncertainty, and doubt, but based on realistic data. Data on cost that can be talked to the project manager, address the problems as early as possible in SDLC. Use a metric for cost-benefit analysis integrated in the risk management. And this is the return of security investment. There are different formulas out there. The one that found the best from our perspective is the one defined from the Microsoft Information Risk Management Guideline. Adopt a formal process to build security in SDLC based upon two approaches. You can build your own framework based on your best practices, or you can adopt a security enhanced model, and there are out there several that you can use. Importantly, have a plan for the implementation. Don't shoot for the star right away. Assess, implement, and verify step by step. Have a tactical plan of activities where you can show the benefit and the business case in the immediate time, and then have a strategic plan for what you can do next. Integrate the software security, information security risks in order to make a strategic decision about how to remediate the overall risks. So take into account the business impact as well as technical impact. And again, you have to integrate with the risk management procedure and guidelines that you have already in place. Can be CRAM, can be Octave, depends on the organization. Then finally, review the business case and commit to it. When you have a way to measure and to assess and measure your risks, then you have a way to evaluate and make informed decisions. Importantly, commit at different level of the organization. You can wait like Bill Gates did with the initiative of the memo from the top down to have the SDLC implemented, but it's better off if you get perhaps support at different level from the decision makers of the organizations, and then you follow up through different competencies on the business side and the technical side. Without commitment, people, technology, and processes, there is no, basically, SDLC. And I'm here for your questions. Yes? Well, there are not so many other frameworks out there. Certainly, Microsoft has been revising the most recent threat modeling methodology, and I would say that's the one to go for. There's been a new actually tool also being developed from ASI, Torpedo. They address this new methodology, and this methodology probably is still the leader. There are other methodologies like Trike, I think. The European community also come out with another framework about the threat modeling. But pretty much there's not so much out there as far as the threat modeling framework. Yes. Well, I mean, from the framework of evaluating threat models to actually categorize risks, Stride and Thread are still there, but in the new methodology, I think there is also evaluation of CIA. Means like confidentiality, integrity, and authentication. So we are going towards a pluggable model for risk, which is not just Stride and Thread. Thread for categorization of risk, and Stride for categorization of threats. Okay, if you don't have other questions, we have other links that you can actually look for at Foundstone for the practice of software application security services. I didn't put here the link on the Department of Homeland Security. There's a lot of resources there, and thank you very much for listening despite the hours.